Hello and welcome to today's class. Today we have a topic that is class 12th chemistry chemical kinetics. In today's class we'll be dealing about what is meant by kinetics, what is the feasibility of a chemical reaction, what is the rate of a reaction, what is meant how we can express the rate of a chemical reaction, that is average rate and instantaneous rate of a chemical reaction, and the graphical representation of rate of a chemical reaction. So let us begin it. What is feasibility of a chemical reaction? In our last year, that is class 11th, we were studying thermodynamics. Thermodynamics always deals with the feasibility of a chemical reaction. That means whether a reaction will proceed or not. It can be determined by certain factors like delta G, Gibbs free energy, delta S, and such on. If delta G is negative or 0, it will be 0 means it will be equilibrium, and it is negative, that is less than 0, then it will be considered as a spontaneous reaction. For example, all the natural processes like food getting spoiled, rusting of iron, etc. So these all are determined by the factors delta G, delta S, and thermodynamics. Here we are studying about a topic which is kinetics. Kinetics describes the reaction rates and mechanisms of reactions by which we can compare two reactions as slow reaction and fast reaction. Moderate reactions are also there. For example, rusting of iron is usually considered as a very slow reaction, whereas precipitation reactions, which we usually do in the laboratory, are normally fast reactions. For example, the food which is getting spoiled, the expiry dates written on the packets of food. So they are calculated on the basis of at what time or after what time the food gets exposed to atmospheric conditions and oxidized. There sometimes on some food materials it is written that the food has to be kept in a closed container. It should be always kept under particular temperatures, like less than 10 degrees Celsius it should be stored. So there we are having different factors which will affect the rate of chemical reactions. Okay, so this branch of study which deals with the rates of chemical reactions and the factors which affect the rates of chemical reactions is called chemical kinetics. Now what do you mean by rate? Rate is nothing but the speed of the reaction, whether a reaction is slow or fast. Now let us come to a definition of rate of chemical reaction. So in our normal language, the rate or the speed is governed by the direction, that is the distance or the direction in which the distance is proceeding with respect to time. Here also, the rate of a chemical reaction is determined by the change in concentration of the reactants or products with respect to time. Okay, say for example, you have a reaction A plus B giving C. So here A and B are the reactants and C is the product. So you can determine the rate of a reaction by looking at the concentration of A, whether it is decreasing, looking at the concentration of B, and looking at the concentration of C. So what is the change in concentration of A with respect to a particular time, or what is the change in concentration of B with respect to a particular time? It will be always decreasing if the reaction is moving forward. Rate of a chemical reaction can also be determined from C, where the product C will be having an increase in concentration. So that is change in concentration of the product with respect to time. So increasing concentration of product or decreasing concentration of reactant. Either ways you can determine the rate of a chemical reaction. So here the same thing is written, reactants to products. The change in concentration is delta R is equal to R2 minus R1. Delta P is equal to P2 minus P1. So here the delta sign actually involves a change in concentration. Say for example, the reactant was initially 10 liters it was there, and then later it changed to 5 liters. So what is the change? 10 minus 5, that is 5 liters is the change. Okay, in the product side it was 2 liters in the beginning and then it changed to 18 liters. So what is the change? That will be the delta P. Now, the square brackets usually represent the concentration in moles per liter or molar concentration. So, the unit is actually shown there. Moles per liter, if you write the concentration, it will be square brackets. Okay, and when we write the expression for rate of a reaction, we can write a minus sign. The minus sign is always kept for the reactants and a positive sign is kept for the products. Okay, it is conventionally allotted minus for reactants and positive for products. So rate of a reaction can be expressed as minus delta R by dt or plus delta P by delta T. Now let us look at the two types of reactions. Reaction rates. They can be expressed as average rate and instantaneous rate. Now let us look at this type of a reaction. This is a general rate of a reaction. In which AA plus BB giving CC plus DD it is given, and how we can find out if the stoichiometric coefficients are A, B, C, D, etc. In that case, we have to write as minus delta minus 1 by A, minus 1 by B, plus 1 by C, plus 1 by D. The unit of the rate of a reaction can be determined by taking the unit of rate divided by that of time. So, moles per liter divided by seconds. The same thing can be expressed as 2 average rate, which will be always like this triangle, it will be there. That is a large deviation is there, delta R by delta T. Whereas instantaneous rate is always measured at a particular point of time. That means the interval will be very less. So that is why we use the differential sign, that is minus dr by dt or is equal to plus dp by dt. So the difference between an average rate and instantaneous rate is average rate is measured for a larger time period, whereas instantaneous rate is measured at a small time period. We can say that delta t is approaching 0. That means the time period or the difference in time is very less. That means you have to say t is equal to 13 minutes or 13 seconds, like that we have to say. Whereas this one means time period is mentioned, that is 2 minutes is a time period. So let us study once more the average rate and instantaneous rate using a graphical representation. Here you can see in the curve of concentration of reactants versus time. Here reactant is mentioned as 0, which means the initial concentration of the reactants. Later it has become R1 and R2 with the respect of time. As the time is going on, the reactant concentration is going on reducing. That is why you are seeing this type of a negative plot. Here, if you take two concentrations, that is R1 and R2 at two different temperatures, T1 and T2. You can find the difference, that is delta T and here delta R. If you take the fraction, that is delta R by delta T, you get the average rate. Okay, so this is called average rate of reaction. Now, if in this tangent you take a particular point of time and draw a line, and from that correspondingly you take time and concentration and then take dr by dt, that slope will you give you the instantaneous rate. So that means it is at a particular instant the rate is calculated. This is the difference between average rate and instantaneous rate. Now let us do some questions for the following. Express the following reactions. Average rate of reaction. So here some equations are given. First one is carbon plus oxygen giving carbon dioxide. Okay, so how to write down the expression for average rate? So you can write the expression as delta C, concentration of delta C divided by delta T. Remember, it will be a minus sign, which is equal to concentration of delta O2 divided by delta T is equal to plus concentration of delta CO2 divided by delta T. Same way, there are some other questions given. 2 mg plus O2 giving 2 mgO. So here you are having balanced terms. So keep in mind how to write the balanced term. You have to write minus 1 by 2 delta mg by delta T is equal to minus delta O2 by delta T is equal to plus 1 by 2. Again it will come because you have got a 2 coefficient delta MgO by delta T. Same way you can write for the third reaction, N2 plus 3H2 giving 2NH3. So here remember it will come 1 by 3H2, 1 by 2 NH3. Okay, and this is for average rate. Suppose you have to write instantaneous rate also. So let us write for the third one, that is instantaneous rate. How we can write? You will write d of N2 divided by dt. This will be a negative sign, is equal to minus 1 by 3 d of H2 divided by dt is equal to plus 1 by 2 d of NH3 by dt. So the last one I have written is actually instantaneous rate of reaction. Now let us look at this numerical. For a reaction R giving P, the concentration of reactant changes from 0.03 molar to 0.02 molar in 25 minutes. Calculate the average rate of reaction in both minutes and seconds. So from the question you have got the time interval, that is 25 minutes, so that will be delta T, and what is the difference in the concentration of reactants? That will be 0.01, and you can find out T what is the rate. Rate is equal to concentration difference divided by time. So 0.01 divided by 25. Here the time is taken in minutes, so you will get the unit value in moles per liter per minute. Okay, now once we convert it into seconds, we'll get it in moles per liter per second. Next question is in a reaction 2A giving products, the concentration of A decreases from 0.5 moles to 0.4 moles in 10 minutes. Calculate the rate during this interval. Same format we have to follow, but only remember that it is 2A, so you have to put minus 1 by 2 delta A by dt. Okay, so minus 1 by 2, the difference divided by time interval, which is in minutes. The answer you will get in minutes. So thank you today. Next class we'll see the factors affecting the rate of a reaction. What are the factors it will be there, that will deal in the next class.